Hello everyone, myself Manju Sharma from Suresh Kanvyar University, Jagatpura, Jaipur. Department is School of Agriculture. Today we are going to talk about farm waste management and their recycling in organic farming. Organic farming Organic farming is the production of crops and livestock without the use of synthetic chemical and inorganic fertilizers. Farming system to grow crops with avoiding the synthetic fertilizer, herbicides and pesticide is called organic farming. Organic agriculture aims at human welfare without any harm to the environment, which is the foundation of human life itself. Farm waste, farm waste agriculture, farm waste, agriculture waste is composed of organic wastes like animal excrete in the form of slurries and farmyard manures, spent mushroom, compost, soil water, and silage influent include natural waste, animal waste, and plant waste. Organic farming creates the best possible relationship between earth and human. This locates Indian experience in organic farming. The farmers in India and China are known as the farmers of organic farming since history. It is definitely true that India had witnessed a tremendous growth in agriculture production in the era of Green Revolution. The technologies involved during the inception of Green Revolution supported by policies and further propelled by agrochemicals, machinery, and irrigation were the main driving forces for the enhanced agriculture production and productivity. Organic agriculture is a system that relies on ecosystem management rather than external agriculture inputs and is found to be more superior than conventional farming. A major challenge today is certainly the transformation of organic products into commodities. Consumers have become more health conscious and they have started to spend more greener, healthier, and natural food. After almost a century of development, organic agriculture is now being embraced by the mainstream and shows great promise commercially, socially, and environmentally. The organic management area in India has increased by about 26 fold in last years. Annotation like USDA, organic farming is a system which avoids or largely excludes the use of synthetic inputs and to maximize the extent feasible rely upon crop rotation, crop residues, animal manures, or farm organic waste, mineral grade rock additives, and biological system of mobilization and plant protection. FAO Organic agriculture is a unique production management system which promotes and enhances agroecosystem health, including biodiversity, biological cycle, and soil biological activity. According to IFOAM, all agriculture system that promotes environmentally, socially and economically sound production of food and fiber. The central dogma of organic agriculture, the principle of health. Organic agriculture should sustain and enhance the health as one and individual. The principle of ecology, organic agriculture should be based on living ecological system and cycles, work with them, emulate them and help sustain them. The principle of fairness, organic agriculture should build on relationships that ensure fairness with regard to the common environment and life opportunities. The principles of care, organic agriculture should be managed in a precautionary and responsible manner to protect the health and well-being of current and future generation and the environment. Interest in the switch over from conventional to organic farming techniques that are relevant in this regard are high premium, low investment, less dependence on money lenders, synergy with life form, and having a traditional knowledge that the farmers have. So this doesn't pollute the soil or result in the wastage of water. As a result, the farmer's income increase to great extent in rural India. The use of naturally occurring matter for increased productivity, disease resistance, and pest control was always in use since time immemorial. The concept of organic farming has been given a special relevance in Rig Veda. Most businesses define waste as anything that not creative value. Widely known, the livestock production has great potential for environmental degradation. As a result of this activity, a large volume of gases, organic material, bacteria, and other substances are produced, posing a risk factor for air, soil, and water contamination. Ruminant manure is a valuable resource as a soil fertilizer, providing both macro and micronutrients required for the plant growth and is a low cost alternative to mineral fertilizer. However, unmanaged and overproduction of the manure from intensive production have led to inappropriate and discriminate application, resulting in over fertilization, soil toxicity, dispersal of pathogen, odor, water pollution, and increase in greenhouse gas emission. Composting and vermicomposting are two of the best known processes for the biological stabilization of solid waste. Objective of dairy farm waste management: eliminate threats of waste, convert waste into useful things, upscaling, modify the wastage, stops offensive odor from waste, prevention, and destruction and disposal of waste. Waste management in dairy farm layout. Common livestock waste like dung, urine, placenta, stillbirths, post-mortem debris, bedding, feed wastage, milk house wastage or wash, dead animals and birds, slaughterhouse waste, hair, hoof and horns, etc. Types of livestock farm waste like solid, in which included dung, feed, bedding, and carcass, liquid, urine, and washing. In gaseous like methane, carbon dioxide, or ammonia. Composting. Composting is a method in which organic matter present in agriculture waste is decomposed by aerobically and anaerobically through a biochemical process and converted into humans. Compost, the aerobically decomposed remnants of organic management of organic matter used in landscaping, agriculture as a soil conditioner and fertilizer, useful for erosion control, wetland construction, and landfill cover. Compost serve as a growing medium or a porous, absorbent material that hold most moisture and soluble mineral, providing the support and nutrients to maximize plant growth. It is sometimes necessary to dilute with soil or peat to reduce salinity or to add neutralizers like pH should be closer 7. Additional nutrients like fertilizer or manure and materials to improve drainage and aeration, sand or clay granules. Compost types. There are different ways to compost starting with layers of brown and green biodegradable waste mixed with garden soil. Brown waste like old straw, tough vegetable stems, green waste in which biodegradable waste that break down faster such as fruit and cut flowers. There is also vermicomposting, which uses worms to help break down the organic waste. Composting is divided into three-step operation like preparation of agricultural waste, decomposition, and product preparation and marketing. Preparation of agriculture waste shall be free of material that is not produced in agricultural field, shall be reasonably free of dirt, soil and visible surface, shall be arranged so that it will be burned with a minimum of smoke. Decomposition. Waste is decomposed by three-way like Nadeb system, vermiculture decomposition, and anaerobically decomposition. like raw materials, organic matter, including carbon, chemical energy, protein, nitrogen, mineral, including nitrogen and other nutrients. Then finished compost, organic matter including carbon, chemical energy, nitrogen, protein and humus, minerals, water and microorganisms. So there is a compost pile in which oxygen is involved, then microorganisms, then due to by using all the raw material. After that, it will be converted into water, CO2, and heat. Bokashi, Japanese for fermented organic matter, is a method of intensive composting commonly made with only molasses water, and wheat bran, can be made by inoculating any organic matter with a variety of hosts of beneficial bacteria microbes. So this includes manure, spent mushroom, compost mushroom, mushroom spores, forest soil, tea, yeast, pickles, wine and beer. Molasses feeds the microbial cultures as they inoculate the organic matter. Vermicomposting, ruminant manure characteristics. It is a modified system of composting in which instead of microorganisms, certain earthworms degrade the manure through their feeding and elimination. The amount and nutrients content of fishes excreted are highly variable and depend on types of animals, animal weight, diets, livestock productive system, and apparent digestibility. Advantage of vermicompost: improve soil aeration, texture, and water retention capacity of soil, improves nutrient status of both plant and soil, then promotes better root growth and nutrient absorption, and it does not have any adverse effect. So this is the vermicompost. Like always, vegetables, fruits, shredded newspaper, and sugary cardboards. It may be always. Sometime coffee grounds, wheat is called when it is called, then eggshell legumes. But like citrus, peppers, onion, and garlic, animal product, bread, or grains, it should be never goes in vermicompost. Sustainable waste management and bioenergy production from livestock, the importance of biogas. So, one of the beneficial and advantageous process in manure treatment is an anaerobic digestion. The AD of various organic feedstocks, predominantly animal manures and municipal wastewater sludges, pre-gaseous mixture called biogas produce a methane rich. The biogas produced consists of methane 50 to 80%, carbon dioxide 20 to 50%, and traces of, for example, hydrogen sulfide 0 to 4%. Biogas technology offers a unique set of benefits. It can improve the health of user, is a sustainable source of energy, benefits the environment and provides a way to treat and reuse. So biogas technology offers a unique set of benefits. Biogas can be used for different energy services such as heat, combined heat and power, and vehicle fuel, although the latter requires upgrading. Advantage of biogas technology: reduced pathogens, reduced disease transmission, low cost energy source, cooking, lighting, etc. Reduce the pathogen, reduce disease transmission, low cost energy source like cooking, lighting, etc. Low cost fertilizer like improved crop yield, improved living condition, improve living conditions, improved air quality, and reduce the greenhouse emissions. That is a biogas plant. Here, slurry and soil will be mixed. Then, uh, inside there is the digester and gas tank, soil, then manure and fertilizer, and that will be outlet. Landfill, a landfill site, rubbish dump or dumping ground is a site for the disposal of waste materials. By burial have been most common method. Some landfills are also used for waste management purpose such as sorting, treatment or recycling. Sanitary landfill. Waste is compacted and covered with soil when disposal site has reached its capacity. A final layer of true fit is applied. That is the sanitary landfill. Recycling process to change waste into new products like prevent waste of potentially useful material, reduce the consumption of fresh raw materials, reduce energy uses, reduce air pollution from incineration and water pollution from landfilling, lower greenhouse gas emissions, and key component of modern waste reduction, and is the third component of the reduce, reuse and recycle. Management of recycling agro wastes like biogas, biofertilizers, then later industries, leather industries, meat, alcohol production, fuel, phosphorus and calcium, and pulp and paper. EM technology. developed by Professor Higa in 1892, was used in agriculture and environment field. Thereafter, EM has been for animal husbandry, industry, human welfare, education, construction, and medical field. EM, that is complex microorganism solution. It contains mainly three species such as lactic acid bacteria, yeast, and phototropic bacteria. Collected from food industries and nature, all microorganisms in EM are non-genetic bacteria. Types of EM: lactic acid bacteria like Lactobacillus plantarum, Lactobacillus casei, Streptococcus lactis. Photosynthetic bacteria like Rhodopseudomonas, Polystress, Rhodobacter, Sphaeroides yeast, Saccharomyces cerevisiae, and Candida utilis. Then actinomycetes, Streptomyces albus, and Streptomyces gracieux, and fermenting fungi are Aspergillus oryzae and Mucor helimalis. Lactic acid bacteria like Lactobacillus, Lactococcus, Propionibacterium, Streptococcus thermophilus, and photosynthetic bacteria. Manure handling and storage. Livestock manure is classified as either a solid, semi solid, or liquid using the following criteria. Solid, it contains greater than 20% solid. Bedding material contributes to the solid content of the human. It can be extracted and handled by any equipment that will move bulk material. Semi-solid, also referred to as slurry, it contains 5 to 20% solids. Semi-solids manure is produced in livestock housing system where limited bedding is supplied, so the resulting semi-solid does not flow readily as liquid manure, nor can it be filled like solid manure. Liquid, it contains less than 5% solids. The additional liquid comes from washing and spillage from watering system. When agitated, liquid manure can be pumped or moved by gravity flow. Contains less than 50% solid. An additional liquid comes from washing and spillage from watering system. When agitated, liquid manure can be pumped or moved by gravity flow. Milk house, wash water, and other types of wastewater are often added to the liquid manure. Manure which includes bedding or waste feed will require dilution if it is to be handled as a liquid. Liquid, it contains less than 5% solids. The additional liquid comes from washing and spillage from watering system. When agitated, liquid manure can be pumped or moved by gravity flow. Milk house, wash water, and other types of wastewater are often added to the liquid manure. Manure which includes bedding or waste feed will require dilution if it is to be handled as a liquid. The moisture content of the manure determines the types of handling and storage system. Most new swine and dairy operations use liquid system while the majority of beef and poultry producers on Prince Edward Island have solid manure handling system. Like this one is the liquid manure storage and circular concrete tank. Storage, a manure storage facility which is of sufficient size reduces the chance of pollution from spills and allows land application to take place when soil is dry, when crops require nutrients, and when work schedules permit. Manure storage should be large enough to store manure, bedding, waste feed, precipitation, and all liquids for at least 2 to 10 days. A 1 year storage capacity is optimal. On PEI, the required volume of open manure storage and confinement yards will have to be increased by zero point 0.6 cubic meters per square meter, like 2 cubic feet per square or surface area, to allow for precipitation. Waste storage management, like reduced waste forage by storing bales of hay under cover. Harvest and store only as much forage as will be required for the coming year. Harvest silage at the optimum moisture content to minimize the potential for seepage. Use of waste forage as a mulch to provide from soil erosion in recently harvested potato field rather than hauling it is the wood, goats or burning it. It will be add organic matter to cultivated soil, compost waste, hay and silage. So this will require addition of a nitrogen source such as manure. Like this is the waste forage being used as a mulch for erosion control after potato harvesting. Modern technology in organic farming, demand is on the rise for organic produce. A survey by the Organic Trade Association found the sales revenue from organic food in the US had exploded to 25 billion by 2009, 25 times that of in 1990. Organic farmers can't use the same technology as conventional farmers like pesticides and genetic engineering to increase yield. There is a mis- misconception that this stubbornly shun technology, preferring age old tradition over modern method, but it's not true. So these farmers can use their understanding of natural process, the mating habits of pest, for example, to optimize yield and care for their crops. Then the surprising result can make you wonder where to draw the line between technology and nature. The trades of technology, pesticides, herbicide, and fertilizer save time and labor in conventional farming, but the resulting efficiency comes at a cost. The production, transport, and use of these substances threatens water quality and leaves a sinister carbon footprint. The runoff causes algal blooms in the Gulf of Mexico, draining oxygen from the surrounding area and kill nearby fish. So, from the surrounding area and killing the nearby fish, with more natural farming methods, organic farmers avoid damaging the environment. These examples reveal how technology can help even while adapting to natural processes. Fertilization and yield. To increase yield, conventional farmers used chemical fertilizer, but mechanically tools it is very good. The roller crimper, a device dragged by a tractor through alfalfa and hay field during harvest, breaks down the cell wall of plant stems to accelerate decomposition. This man-made tool increases soil fertility by spreading up the natural decomposition process without artificial chemicals. Another simple innovation that can increase yield quantity in organic farms is the hoop house, which is very much like a greenhouse, only easier, faster, and cheaper to build, consisting of raised beds in a walled off piece of land. It extends the growing season by protecting crop from bad weather and keeping them warm. More crops can then be produced for the local market, avoiding the need to import them from another location. Then, which of the so this research oriented improvement helps farmers increase yield and benefit financially in a clean way. Thank you. Now, International Control System. So, as per IFOAM and NPOP definition, internal control system, that is ICS, is a documented quality assurance system that allows the external certification bodies to delegate the inspection of individual group members to a body identified from within the operators of the group. So this can be legally recognized farmers association, cooperatives, NGOs or exporters project or a farmer group. This means in practice that a growers group basically controls all farmers for compliance with organic production rules according to defined procedures. So, the organic certification body then mainly evaluates whether the ICS is working well and efficiently. So, the ICS guards the integrity of the organic quality of the products, particularly in smallholder products. Then, certification agencies in India. Bureau Varieties Certification India (BVCI) Private Limited Mumbai, EcoCert India Private Limited Aurangabad, IMO Control Private Limited in Bangalore, Indian Organic Certification Agency Indocert in Kerala, and Lacon Quality Certification Private Limited Kerala. One Card Asia Agri Certification Private Limited Rajasthan, SGS India Private Limited Haryana, Control Certification Mumbai, Uttarakhand State Organic Certification Agency USOCA Dehradun, APOF Organic Certification Agencies AOCA Bangalore. Then Rajasthan Organic Certification Agency ROCA Jaipur, Vedic Organic Certification Agency Hyderabad, Indian Society for Certification of Organic Products, that is ISCOP, Coimbatore, Food Cert India Private Limited Hyderabad, Aditi Organic Certification Private Limited Bangalore, and Chhattisgarh Certification Society CGCERT Raipur. Tamil Nadu Organic Certification Department, that is TNOCD, Coimbatore, Intertech India Private Limited Delhi, Madhya Pradesh State Organic Certification Agency MPSOCA Bhopal, and Bioscent India Private Limited Indore. Export Inspection Agency EIA Delhi, Odisha State Certification Agency OSOCA Bhubaneswar, Natural Organic Certification Agro Private Limited Pune, Fair Certification Services Private Limited Madhya Pradesh. So all the above certification bodies are accredited under NPOP, Ministry of Commerce, Government of India, Apex Body for NSPO, Ministry of Agriculture, Horticulture, APEDA, Coffee Board, Tea Board, Spices Board, Coconut Development Board, Cocoa and Cashew Nut Board are members in steering committee, so they will be administering and developing national accreditation policy and programs to implement national organic program. Now, international inspection and certification agencies. First is the SACAL in Netherlands, EcoCert France, Belgium, Germany, IMO in Switzerland, Organic Crop Improvement Association in USA, Demeter Association in USA, Soil Association, Soil Association Inspection in UK, California Certified Organic Farmers CCOF accreditation agencies, APEDA, Agriculture and Processed Food Products Export Development Authority, Coffee Board in Bangalore 1942, Tea Board Kolkata in 1953, Spice Board in Kochi in 1987, Coconut Board Kochi 1981, Cocoa and Cashew Nut Development Board, Kochi in 1981. In turn, these accreditation agencies have inspection and certification agencies. These agencies directly contact farmers, organic input producers, processors, and marketing agencies. Organic logo, a trademark India Organic will be granted on basis of compliance with National Standard for Organic Production, that is NSOP, owned by Government of India. After that, organic market. The organic food production costs are higher in the development countries as organic farming is labor intensive and labor is costly in these countries. However, in country like India, where labor is abundant and is relatively cheap, organic farming is seen as a good cost effective solution to the increasing costs involved in chemical farming. Currently, most of the organic farmers in India are still in the transition phase and hence their costs are still high. As these farmers continue with organic farming, the production costs are expected to reduce, making India as one of the most important producer of organic food. Area as on 31st March 2020, total area under organic certification process registered under NPOP is 3.67 million hectare. This includes 2.299 million hectare cultivable area and another 1.37 million hectare is for wild harvest collection. Among all states, like Madhya Pradesh, has covered largest area under organic certification, which followed by Rajasthan, Maharashtra, Gujarat, Karnataka, Odisha, Sikkim, and Uttar Pradesh. The production India produced around 2.75 million in 2019 to 20 tons of certified organic products, which includes all varieties of products. Madhya Pradesh is the largest producer among all different states. Export Total volume of export during 1920 was 6.389 lakh million ton and the realization was around INR 4,686 crore. So exported to different countries like USA, Europe, Canada, Switzerland, Australia, Japan, Israel, UAE, New Zealand, Vietnam, etc. So the major domestic markets in India are Bangalore, Chennai, Delhi, Hyderabad, Mumbai, upper and urban middle class areas. Thank you.